Hello students, let's start a new chapter, Probability Exercise 25A. Now what is probability? Now this is a term that will tell us the likelihood of something happening. Will this happen or not? Is it likely or unlikely? Now let me help you with this. Let me tell you with this. Now here I have a point marked here at this end, and here also we have a marking. Now there is a point in the middle. Okay, so this is one end, this is the other end, and this is the halfway point. Now here let me mark this as 0 and this as 1. That means this will be in between 1 out of to half of this 1 by 2. Now, with the help of examples, let me explain what probability is. Now, what are the chances of a lion flying? There are no chances at all, isn't it? It's impossible that a lion will fly. So, we say it is impossible and the probability is 0%. 0%. It's impossible for a lion to fly, so the probability is 0%. Now, what about the chances of the sun rising tomorrow? It is certainly going to rise, isn't it? That means we say it is certain and we put it in this extreme. That means there are 100% chances that the sun will rise tomorrow. That we know for sure. Now, this portion in between impossible and certain is our probability. That means if it is closer to 100%, that means there are chances that that will happen, that event will happen. And if it is closer to 0%, that means there are chances that that will not happen. Now, suppose it is a cloudy day, then we say that it is likely that it will rain. So this in-between portion is 50%. Now we are going to say it's likely that it's going to rain. So that means it is closer to 100. It is more than 50% because it is a cloudy day. So we say it is likely. It is likely to rain. Now suppose it's a very dry day. The skies are very clear. There are no clouds in the skies. Then we say that the chance of rain is less, isn't it? It'll be closer towards 0, from 50 to 0. So we say that it is unlikely to rain. So the terms unlikely and likely are what we are going to be using in probability. Now, when we study this in maths, there is a particular way that we do it. So, first of all, probability is used to describe how likely or unlikely it is that something will happen. And in maths, we say probability P, we use the capital letter P, is the number of favorable outcomes divided by the total number of outcomes. Now, this will tell us the probability of something that is going to happen. If it is going to happen or if it is not going to happen. If it is more than 50%, then there are chances that it will happen. If it is less than 50%, then it is that it might not take place. Let me explain this with the help of an example. Now here I have 1, 2, 3, 4, 5, 6. 6 smiley badges. Okay, now we are going to find the probability of picking one of these badges. Now suppose I have these 6 smiley badges in a little box and I pick one. Now what are the probability of getting a yellow smiley? Okay, so there are so many smileys. I have 2 yellows, I have 1, 2, 3 blue smileys, and I have 1 red smiley. Now all 6 badges are in a box and I randomly pick one. What are my chances or what is the probability of getting a yellow smiley? So how do I do that? I use this formula which says number of favorable outcomes. That means I'm thinking of the yellow badges. How many are there? 1, 2. So there are 2 badges. So that will be my favorable outcome divided by the total number of outcomes. That means totally how many badges do I have? 1, 2, 3, 4, 5, 6. So that will be 2 divided by 6. And then I reduce this to the lowest term. 2 ones are 2, 2 threes are 6. So I get 1 by 3. So my chances or my probability of getting a yellow smiley is 1 out of 3, 1 by 3. Now I can have this as a fraction or I can convert it to a decimal number. So when I convert this to a decimal number, I get 0.33. If I have to make this a percent, it is 0.33 into 100, which is 33%. So my chances or my probability of getting a yellow smiley in a box of so many smileys is only 33%. So it is unlikely. Okay, slightly unlikely. Now let's go on. What is my probability of getting a blue smiley? So here also to find my chance of getting a blue smiley. So again, I have these 6 badges in a box. I'm just going to randomly pick one. And what are my chances that that one which I picked is a blue smiley? So we are going to use this formula again, number of favorable outcomes. That means how many blue smileys do I have? I have 3 blue smileys. And what is the total number of outcomes? There are 6 smileys altogether. Now I can reduce this to the lowest term. 3 ones are 3, 3 twos are 6. So what is my answer? 1 by 2. 1 by 2 is half. So now if I convert this to a decimal number, it becomes 0.5. And if I have to make this a percent, that is 0.5 into 100 is 50%. So what are my chances of getting a blue smiley? It's 50%. I can get or I might not get. It is likely or unlikely. Whereas here it is unlikely. Here it is likely or unlikely. Now let's see what is the probability of getting a red smiley. So here again, number of favorable outcomes means how many red smileys do I have? 1. And what is the total number of outcomes? Total number of badges is 6. Now, this is a fraction 1 by 6. So my chance of getting a red smiley is 1 out of 6 chances. If I convert this to a decimal number, I get 0.17. If I have to convert this to a percent, I multiply 0.17 into 100 and I get 17%. Now 17% is less than 50, isn't it? It's less than 50. That means it is highly unlikely that I'm going to get a red smiley. So if there is a box of 6 smileys of different colors, what is my probability of getting a yellow smiley? 33% chances. It is little unlikely to get one. What are my chance of getting a blue smiley? It is likely. It is 50%, 50% chances that I will get a blue smiley. And what are my chances of getting a red smiley? It is highly unlikely because it is closer to 0. 17 is closer to 0. So this is a formula that we are going to be using in all our questions. So let's begin our exercise 25A. This is found on page number 273. Now question 1. A coin is tossed once. So all of you know coins, you have your heads and tails, remember? Now we have to find the probability of getting a head and not getting a head. So a coin is tossed once. So we're going to toss a coin and then we're going to see what are the chances of the coin falling in such a way that we get a head. Okay, and what are the chances of not getting a head? So we should always keep in mind we need to get two things. One is the total outcomes. Then we have to get the favorable outcome. With the help of this, you can find your probability. So let's begin by saying the total number of possible outcomes. What are the two outcomes? Head and tail. So the outcomes are 2. So this is the total number of outcomes. Now here we're going to talk about getting a head. That means the number of favorable outcomes. We're talking only about head, and head there's only one. There's one, isn't it? So now to find the probability of getting a head, you can put the letter P, capital letter P. This stands for probability. What is the probability of getting a head? So what are the number of favorable outcomes? The number of favorable outcomes is 1. That means how many heads are there? Just 1. And total number of outcomes? 2. So what is my answer? The probability of getting a head is 1 by 2. And as we saw, 1 by 2 is half or 50%. There are 50% chances of getting a head. This is my first answer. So the probability of getting a head is 1 by 2. Now the next question is probability of not getting ahead. So again, this time total number of possible outcomes, head and tail, is 2. Number of possible favorable outcomes, here again there's only one head. Of not getting ahead means that means the other one is tails, so there's only one there. So now the probability of not getting ahead, the formula is here. Number of favorable outcomes is 1. The total number of outcomes is 2. So now 1 by 2, we can't reduce it further. So again here the answer is 1 by 2. I have 50% chances of getting ahead and 50% chances of not getting ahead because there are only two possible outcomes. Question 2. This time a coin is tossed 80 times. So this will be the total outcome, 80 times. And the head is obtained 38 times. Now if a coin is tossed once, what will be the probability of getting a tail and getting a head? Okay, so first, now the total number of possible outcomes is 80. Now here we are talking about the head is obtained 38 times. So what is the probability of getting a tail? That's the first thing. So the number of favorable outcomes of getting a tail. Okay, remember 38 times we get the head. So to find the tail, we just have to subtract 80 minus 38, we get 42. So the number of favorable outcomes of getting a tail, that is the meaning of favorable outcomes, we have 42. Now to find the probability of getting a tail, we have to use this formula. So that will be 42 is the number of favorable outcomes and the total number of outcomes is 80. 42 divided by 80. This we can reduce it to the lowest term. We can divide 42 and 80 by 2. 2 2's are 4, 2 1's are 2, 2 4's are 8 and the 0. So what do we have? 21 by 40. So my answer here is 21 by 40. So what is the probability of getting a tail? It is 21 by 40. Now the next one is, again, we have to find the probability of getting a head. So the total number of possible outcomes we know is 80 and we've already been told that number of favorable outcomes of getting a head. Okay, here it says 38. So 38 times we get. Now to find the probability of getting a head, use the formula. So this time we say 38 divided by 80. Again, let's reduce this to the lowest term. 2 into 19 is 38. 2 into 40 is 80. So what do we have? We have 19 by 40. So here the answer is the number of the possibility or probability of getting ahead is 19 by 40. So we're leaving it as a fraction. If you're asked to convert it to a decimal number or a percentage, you can do it. So right now we leave it as a fraction. Question 3. A dice is thrown 20 times and the outcomes are noted as shown below. That is, sometimes when you throw the die, you will get 1 or 2. You have all these numbers up to 6, isn't it? The different faces have different numbers. So when it was thrown 20 times, the number 1 came 2 times. The number 2 appeared 3 times. And they got 3 4 times, 4 4 times, 5 3 times, and 6 4 times. So these are the outcomes and these are the number of times that these numbers took place, happened. Now, a dice is thrown at random. Find the probability of getting 3. So, of all these numbers, we have to find out what are the chances or probability of getting the number 3. So remember the things that we have to keep in mind. We have to have the total outcome first. So the total outcome is 20. Then the favorable outcome, that is, how many times has 3 occurred? Because we've been asked for 3. How many times has 3 occurred? 4 times. So that is the favorable outcome, 4. Now to find the probability, we have to use the formula. So the probability of getting 3, this is the formula. So number of favorable outcomes is 4 and the total number of outcomes is 20. Now we have to reduce this to the lowest term. 4 1's are 4, 4 5's are 20. So what do we have here? The probability of getting 3 is 1 out of 5. The chances are 1 out of 5. So this is our answer for getting 3. Now we have to find out what is the probability of getting a number less than 3. So similarly, we should have total number of outcomes, favorable outcomes and the formula. So total number of outcomes is 20. Number of favorable outcomes, that means getting a number less than 3. What are the numbers less than 3? 1 and 2. So these are the numbers less than 3. How many times has 1 occurred? 2 times. How many times has 2 occurred? 3 times. So that means number of favorable outcomes will be 2 plus 3. that is 5. So 5 times this has occurred. So now to find the probability, let's use this formula. Number of favorable outcomes is 5 and the total number of outcomes is 20. Now reduce it to the lowest term. 5 ones are 5 and 5 fours are 20. So what is the probability of getting a number less than 3? 1 out of 4 chances. Okay. So 1 by 4 is your answer. Now, what are the chances of getting a number greater than 3? This was our third question. Again, total number of possible outcomes is 20. Number of favorable outcomes means number greater than 3. What are the numbers greater than 3? 4, 5, 6. Now, how many times has 4 occurred? 4 times, 5 3 times, and 6 4 times. So we have to add up all that. So that will be 4 plus 3 plus 4. So 4 plus 3 is 7, 7 plus 4 is 11. So this is 11. Now to find the probability, we have to use this formula. And what do we write here? Number of favorable outcomes is 11. Total number of outcomes is 20. Now this cannot be reduced further. 11 by 20 cannot be reduced further. So this will be your answer. Question 4. A survey of 50 boys showed that 21 like tea while 29 dislike it. Out of these boys, one boy is chosen at random. What is the probability that the chosen boy likes tea or dislikes tea? Okay, so we're going to do this. That means someone went around and spoke to 50 boys and found out that 21 of them like tea and 29 don't like it. Now, out of these 50 boys, suppose you just pick one boy. Now, what is the probability that this boy that we have chosen is one who likes tea or one who dislikes tea? So we are going to find out about this chosen boy. We'd like to find out the probability of the chosen boy liking tea. So we write down what is given to us, the total number of boys, that is 50, number of boys who like tea, 21, who dislike tea, 29. So here, total number of boys will be the outcomes, total outcomes. Favorable outcomes are the number of boys who like tea and the number of boys who dislike tea. Now we are going to find the probability of this chosen boy who likes tea or not. So this is the probability that we are going to find out. So we're going to use this formula, number of favorable outcomes. That means liking tea. So the favorable outcomes will be from this second statement. So that is 21. So 21 divided by the total number of outcomes, which is 50. Now this cannot be reduced further. So the probability of this boy liking tea is 21 out of 50. We have found the answer to the first part. The probability that the chosen boy likes tea is 21 by 50. Now, let's find out the next one. The probability that he dislikes tea, again we use the same formula. Number of favorable outcomes is how many boys dislike tea? 29. And what is the total number of outcomes? 50. So here also we cannot reduce it to the lowest term. So the probability that the boy dislikes tea is 29 by 50. Question 5. In a cricket match, a batsman hits a boundary 12 times out of 80 balls he plays. Further, if he plays one more ball, what is the probability that he will hit a boundary or he will not hit a boundary? That's the question. So, total number of balls it's given to us as 80 that he faced, and out of that the number of times he hits a boundary is 12 times. So 12 times he has hit a boundary out of the 80 balls that he played. Now, number of times he does not hit a boundary will be 80 minus 12. Isn't it? 80 minus 12, that means 68. Then in 68 balls, he has not scored a boundary. He has not hit a boundary. Now, we need to know that if he plays one more ball, what is the probability that he will hit a boundary in the next ball? So, probability that he hits a boundary will be number of favorable outcomes. That is, favorable outcomes here is hitting a boundary. We have to choose it from the second step. That is 12. The number is 12. We take 12 and the total number of outcomes is already given to us 80. So 12 by 80, we can reduce it to the lowest term, dividing it by 4. You can divide it by 2 also. Divided by 4, 4 threes are 12 and here 4 twos are 8, 20. So this is 3 by 20. So the chances are 3 by 20 that he will hit a boundary. What are the chances that he might not hit a boundary? So let's find that also. So here number of favorable outcomes is how many times he does not hit a boundary. That is 68 balls he faced. He did not hit a boundary. The total number of balls he faced is 80. Let's reduce this to the lowest term. 2 3s are 6, 2 4s are 8, and here we have 40. Again we can reduce this. 2 1s are 2, 2 7s are 14, and 20. So this is 17 by 20. So here the probability that he will not hit a boundary is more than this, isn't it? It's 17 by 20, and here hits a boundary is 3 by 20. So the probability that he will not hit a boundary is more than the probability or a likelihood of him hitting a boundary. So these are our answers: 3 by 20 and 17 by 20. We will stop with this for now, children. In our next video, we will continue with the remaining questions. Thank you, children.